Hello everyone, welcome to this series of lectures on object-oriented programming using Java. This is the first lecture in the series and I am your instructor Probidita Roy Chaudhary. So let's get started. So what are the basic concepts of an object-oriented programming language? So before we come to the object-oriented programming concepts, let's start off with what is a program. A program consists of data and code. So you have data, which is but nothing but the variables, and you have code, which is nothing but the instructions. So you have variables and you have instructions, and together they form the program. Now, when you are writing a program, the focus can be either on the code, that means what you are trying to do, what is being done. In this case, if the focus is on the code, on what is being done, on the actions, then this is known as your procedural programming. And that is what you had been doing all these years with basic foundational programming languages like C, BASIC, and so on. So the focus has always been on the code. On the other hand, you may have focus on the data. You may choose to focus on the data, that is, what is being changed. Your program is doing something, and as a result, what is being changed. So, if your focus is on the data, in that case, this is what is known as your object-oriented programming. You focus not on the code, but on the data. Let us look at it from another angle. Okay, so let us say you are supposed to write a function or write a program in C to perform a task. So you're given a task, okay, to perform. So what we do in modular programming, we break down this task into subtasks. So this is task 1, task 2, task 3. Again, task 3 say is quite big, so we break it down into task 4 and task 5. So altogether, I have to perform this task. I have to perform task 1, task 2, task 3, and in order to perform task 3, I have to perform 4 and 5. So the approach that we have always followed is that we wrote functions for each of these. We wrote functions for task 1. So we wrote a function, say function 1, some function we wrote here. For this task, we wrote another function, function 2. For task 3, we wrote another function, 3, okay, function 4 and 5. Okay. Now, if you look at the hierarchy, it is going to be something like this. Somewhere you will have a main function. Okay. The main function calls function 1. Okay, let me write it in a different way. So you have main function. Inside main function, you are calling function 1. You are calling function 2. You are calling function 3. All right. Then somewhere else you have code for function 1. You have code for function 2. And so on. Similarly, you have code for function 3. In turn, function 3 is calling function 4 and 5. Okay. So now the focus now here, we have divided this task into different tasks. So each of this represents something is to be done. That is the action. Now on what data are all these tasks going to operate? That is not our focus anymore. Our focus is only on the task, on the action that is to be performed. So this particular approach, where we break down a task into subtasks and again further subtasks, and then we take the accumulation of all of these into a main function and then we execute it. This approach is known as your procedural programming. Coming back to our slides here. Okay, so that is your procedural programming. On the other hand, now what we are going to see is the focus. Now we are going to move from the data or from the code to the data. How? By using something known as objects. So what is an object? An object is an entity. Let me just write it here. It's an entity, okay, which can be described by using certain features and certain actions or behavior. So it is an entity an object is an entity which has got certain features and performs certain action or behavior, exhibits some behavior. So now you'll see that objects are all around us. It's everywhere. If you look around, you can see you have a computer in front of you or a mobile phone. That is an object. Okay, it has some features. What are the features? It has a screen, it has a touch screen, it has a button. Okay, it has different apps loaded in it. So these are all nothing but features. It has a model. Okay, it is from a particular company, it uses a particular OS. All these are different features which describe the mobile phone or the computer. Similarly, the object, the mobile phone, can perform some actions. What you can do with it? You can switch it on, you can switch it off, you can run some app on it, and so on. So those are the behavior of that object. So if you look around you, you'll find that the whole world is filled with objects. Okay, a human being, also you can think of it as of yourself as an object. Okay, you have a name, you have an age, you have a color, you have gender, you have hair. Okay, color of your hair, color of your eyes, all these describe you. Okay, and there are some behavior, you can perform some actions. So the whole world actually is nothing but your objects. So that is why object-oriented programming is something which is more natural, because we look at the world as a collection of objects. So as I have mentioned, objects are defined by the attributes. So these features, when I say attributes, I mean the features. Okay, so attributes and behavior. So an object is an entity that contains both data. By data, I'm talking about, when I say data, I'm talking about the feature or the attribute and behavior. Okay, so data stored within an object, it represents the state of the object and is termed as attributes. And the behavior of the object represents what the object can do. Okay, so that is your object. Now, before we go on to the 4 pillars of object-oriented concepts, let me again go back to our procedural programming and see why do we need object-oriented programming. So we had our task like this. We had this is the main function, main calls function 1, calls function 2 and calls function 3. Function 3 calls function 4 and calls function 5. Now in all of this, somewhere in the corner lies your data. So this is your global data which is there, and all these modules, okay, can access this global data. Also, when the different modules are interacting with each other, like say 3 here and 4 here, they are interacting with each other. So as they are interacting, they are sending and receiving data to from each other. Okay, similarly 3 and 5, okay, they are also sending and receiving data from each other. So in all of this, there is a high chance that the data that is moving around gets unintentionally tampered. Okay, so, and especially if it is your global data like this, because so many functions are working on it, there is no way by which you can keep track of which data is being used by which function. And if you want to change one function, you have to change all of them. You might have to change many of them. Suppose I want to change 5, then I might have to change 3, and I might also have to change main. Okay, so all these gives rise to something known as your spaghetti code. S-P-H-E, I think the spelling is wrong. Okay, correct it. Spaghetti code. So that is all jumbled up. It's all tangled. All right. So, and this is this condition becomes more serious as you have larger and more complex programs. So this is where your procedural level programming fails. So procedural programming is not suitable for, large, complex problems. And I have already mentioned that objects are all around you, and when you look at things, you always look at it as objects. So the approach towards a problem, when you look at a problem, it is very natural that we look at a problem in terms of objects and their interactions. So object-oriented programming seems like a natural choice for solving any kind of a problem. So it is a natural choice.